So over the last 3-4 years, I've been developing this code using advanced encryption standard 512 to protect the code, like the source code of your application. Because most testers, whether it be the web pen testing or the application pen testing, black box testing or white box testing, there's a loophole in the way of writing the code. If you keep too many blank spaces in your code, the code won't run according to the time optimization techniques which are required according to the industry standards, like to speed up the code or to manage the memory efficiently. And on the other hand, if your code is too big, it will take time to load. So that is the space which is used by hackers using memory forensic tools to actually read or intercept what is going on in your code. So in order to prevent that, I've decided to obfuscate and encrypt in tandem the source code entirely with AES Advanced Encryption Standard 512 so that it's impossible to like reverse engineer, number one, and it's running on a loop. So the hacker, or whether it be the white hat or a black hat or a gray hat, doesn't have or know the number of times the loop is running to deobfuscate the code and run it in the background. So I shall give you a brief demo of how it actually works. So I'll quickly create a simple program. This crypto of mine currently supports Python scripts only. Why I've chosen Python as the primary project because is that Python is used for machine learning projects, AI projects, data analysis projects, even for developing games, music software, and the list goes on and forth. It's even used in the medical field, the military field. So yeah, you can do anything with Python if you want to. So I'll just quickly create an application. So I quickly type a program, maybe a simple program. So this to the developer is a simple program which prints the statement hello world, takes input a number, converts it, typecasts it to an integer, and then prints the typecasted value. So let's see what happens when we just run the program as a normal script. So it prints hello world, enter one, and it gives me the output 1. So when the hacker will get access to the script, he or she can just open the script, understand the logic, manipulate the logic, and get access to the internal workings of the APIs and all that shit. But let's see what happens when we obfuscate and encrypt the code according to AES standards. So I'll call my unique function, and it starts up. Now I shall enter a loop limit, which is nothing but the number of iterations the encryptor will run so as to encrypt the code. So let's enter, say, 100. Enter a key value. Let's enter, say, 10,000 and path to the file. And this also develops into an application so that, it will like use as an executable in any system. So it freezes the entire Python and then it converts it into a Python module. So let's see what it gives me in the output folder. Meanwhile, let's check out the size of a.py. Originally, a.py was 1 KB in size. Right now, if we check it, the size, it's over 5.5 MB. So let's open up the code and check what is there in the code. So it was simply a simple 4-line program, and now it is like more than 1500 lines, I may say. So from here you can see it's AES encrypted, and the hacker doesn't know the number of iterations, as I mentioned before, nor does they know the key to decrypt it. But the question rises, when a code is encrypted, does the code actually run? So let's see what happens. So it has given me the success flag. Now I shall run the code in native form. Take a look at the speed. It's the same runtime and it's running as it should. But the size is humongous for the Python script. And if you like transfer it to any system, be it a Mac, be it an iPhone, be it an Android, it will support all the platforms, because at the end, it's a single script. It has no dependency in it. Now let's go to the disk folder. So you can see I've generated an application of the same, and it's a no windowed application. That is, it doesn't have a command prompt window, but it will run all the same. It runs. It tells me that the window has been like minimized, so it's not showing the input. But if I change the command out there, it will give me a full-fledged console-based program. So if anyone tries to reverse engineer this, they won't get to the actual source code or the logic behind the running of the application. So you can integrate it with any Python programming like concepts, and it will be like hard to deobfuscate the code. Yeah. So any questions, Ken?
Any limitations on size of this Python script I can have? Can I have some massive program and run it through this, or is it limited to just smaller scripts?
You can. Officially, I'll show you another program. So basically, this script of mine, which I'll show you, is around 742 MB. A Python script of 742 MB in size. And let me show you the code. It won't fire up because it's out of memory on this system. It has 16 GB of RAM, but it won't fire up. So let's run the code and see what it can do. Running up, give it around 30 seconds to 1 minute because it's quite a big file.
So while we're waiting on that, though, one thought that comes to mind is, as an attacker, I could use this to obfuscate what I'm doing to get into your, your company's systems. So is there any way to reverse this in any capacity if something like that was happening?
Okay, coming to the question, Ken, like if the hacker tries to modify an application and insert certain malicious code into it,
well, let's just say that I'm the bad hacker and I want to run scripts against your company. Let's just say I'm going to use Python scripts for some reason, or maybe I write even a tool in Python. Do you have a way as a security researcher to really dig in and see what I'm doing, or is this also a benefit to me? So eventually this will obviously be out in the wild, and everyone's going to be using it, this type of technology. Well, what you've built here. So the question is, of course, the good people are going to be using it to try to help out, but can it also be leveraged by the bad people to do their thing as well?
The bad people can't use it technically because this can be bound to a hardware device, like physically bound to a hardware device, licensed to a hardware device, I mean, so that when a legitimate company tries to purchase this software from me or tries to license it, they have to send certain key aspects of the hardware system so that, it gets bound to the system, and it cannot, even if they copy the source code and try to play it on another system, it just simply won't run. So no, even if the hacker gets access to the script, it's next to impossible to execute the code on another system, even using VM.
Yeah, I think it's good. So a question I would have is, this is, you've got this developed. If a company is looking right now and they want to test this out, like, do they just reach out to you, or is there a GitHub repository where this lives or anything? Or
so since it is a very dangerous tool, I've not hosted this on GitHub, so that the hackers or someone doesn't get malicious access to it and use it for malicious intentions. So if they want to use it, they have to reach out to me, and we can take it through. Yeah, and it's highly scalable. And coming to the script, the 742 MB script, it's already executing on the front screen. And let's see what it can do. It actually does encryption using multimedia files, as I've previously come across my different programs. So let's see how it encrypts. It uses Aes encryption as well. So let's see. Yeah. Starting the application. Choosing the key file from the pop-up file manager. So let's choose an application to encrypt an image. Let's see how it goes. I shall go to downloads folder and maybe use the Bandicam setup executive. That's my key file. Now I shall choose the file to encrypt from the file manager. So I go to pictures. I have a screenshot of a distant planet. Let's see what has, yeah, the code has executed successfully. And we have with the timestamp of 10:41 a.m. an AES image, AES file, which is of 4005 KB. And the original image out here is also of size 4005 KB. So it's showing 3.90 MB. That's the conversion rate. So yeah. Now let's see if we can decrypt this. So the time to execute a 742 MB Python file was approximately 2 minutes 45 seconds on an i5 8 Gen with 16 gigs of RAM. And let's see the decryption process. Started. It's 10:42 by my watch. And let's see how far it goes. It will pop up on the screen. Yeah, it started. Starting decryption process. Choosing key file, which is the bandicam.exe. So this removes the use of complex alphanumeric passwords. And it also removes the tendency of using word lists and complex, like complicated word lists, which are long alphanumeric strings, and applications like cracking applications on the Kali OS, on the Parrot OS for guessing your passwords. So we'll choose the file to decrypt, which is located in the current directory with the 10:41 AM timestamp. And it's processed. It is done. And this is your origin, like the decrypted file, the Z1. I'll open up like with the image viewer. Maybe where did it go? Just a minute. Paint maybe. Yeah, that should do. And as you can see, it's decrypted in its nascent form with zero loss of pixels or data, if you may call it. Any comments?
Any plans to expand this beyond Python? So I can immediately see people having questions like, yeah, it's Python, but we want it in X, we want to write it in Golang or something like. So do you have plans to expand this outside of just scripting in Python at some point?
Yeah, at some point when the funding is sufficient, maybe we can do all the languages that exist, because on a limited budget, it's very difficult to get access to multiple systems and development platforms. So yeah, it's possible. And it can also be used for steganography, PKI, the public key infrastructure network, and used for homomorphic encryption. Yeah, there are multiple plans. It's not just based on Python, but you can even embed an executable inside it and call the executable using the eval function, so that it has multiple languages inbuilt, and you can use actually a Golang executable from the Python script or from the Jython script or the Cython script and call it into an application and run it as a native application. So yeah, the opportunities are endless.
Have you tested it in any cloud platforms at all, AWS, GCP, or anything like that, or just locally on the system?
It's on a local system as of now because there's no access to any of the platforms technically. So no one has taken notice of this yet, but yeah, like I just finished the final touches like a month back. So yeah, it's not yet to the like production stage, but for alpha release, it's good enough.
If people want to help on this, so if people are out there and they just want to kind of help contribute, are you allowing that? If, I'm assuming people are obviously going to have to be vetted, make sure they're not a bad person, but is there that option for those out there in the community that want to help on this project with you?
Yeah, I'm quite open to collaboration, but it depends, as you said, on the vetting process, how much you can vouch for the person, how much the integrity is good enough for the project. because this is a noble cause and it's for protecting the non-technical people from the unethical parts of the web, and to be safe, to make the web a safer place. And according to the Gmail attack, as I was talking to you regarding the other day, you can integrate this into the SMTP library of Python, and you can just encrypt your files using this concept and send it across. And even if the Lapsus, if I don't know whether I'm pronouncing the group correctly, gets access to your Gmail, they won't be able to decrypt a single mail of yours because they don't have access to the multimedia key out there. And the multimedia key is like lost in an ocean of files. It can be the Mariana Trench or even at the Himalayan range. They just don't know where the file is located. It can be on your local system, it can be in the cloud, it can be a pen drive. So without that key file, it's impossible to decrypt.